Okay, so let's apply what we know now to some problem-solving situations. Let's look at our first problem here. If Delilah bought pizzas for $12 each, and P represents the number of pizzas she bought, write an expression to represent her total cost. Now, a couple of things to notice here. Each is a synonym for the word per. So we know that when we have the word per, we're going to multiply. So our operation here is multiplication. And I could replace that word each with the word per in this problem. $12 per pizza. Another thing that we want to get used to doing is what's called defining the variable. So we want to locate the variable in the problem, which for us is P, and we want to tell what that variable is going to stand for. That's defining the variable. So here it tells us that P represents the number of pizzas she bought. So I wrote down P equals the number of pizzas purchased. So we know that we're paying $12 for every pizza we bought. We don't know how many pizzas that is, so we just use the variable, and the expression then that we're looking for is 12p, and then that means 12 times p. Okay, here's our next situation. If Gina's recipe calls for 2 teaspoons more sugar than Greg's recipe, and G represents Greg's recipe, write an expression to represent how many teaspoons of sugar are in Gina's recipe. Okay, so some important points. We know that Gina's recipe has 2 teaspoons more than, and we know that more than from the chart that we filled out earlier means plus, so 2 plus something. And then here's our variable, and we want to define that variable. So G, what does it stand for? It says that G represents Greg's recipe, but that's really not enough for us right now. We need to know what it represents about Greg's recipe, and if we read this problem carefully, we'll see that it's the number of teaspoons of sugar in Greg's recipe. So G is the teaspoons of sugar that we find in Greg's recipe. So if we take the number of teaspoons of sugar in Greg's recipe, and if we add 2 to that, because Gina's recipe is 2 more, we'll have an expression that will tell us how many teaspoons of sugar are in Gina's recipe if we knew how many were in Greg's. The best we can do is G plus 2. Okay, your next 2 word problems there will show up in your SWIC to give you some practice with those. Now we're going to do one more type of problem using these algebraic expressions, and that is to write an expression to find the area or perimeter of a rectangle. Okay, let's have a little refresher here on what perimeter and area are. Remember that perimeter is the distance around the outside edge, or the rim. And the way that we compute perimeter is we add all the sides together. And its label will be in units. If it was feet, we would just write feet. If it was inches, we would just write inches. The area is the space inside of a figure, and we compute that by multiplying length times width, or another way to say that is base times height, and it will be labeled in whatever the units are, squared. Alright, so to find the perimeter of our first shape here, we need to remember something that's true about rectangles, and that is that opposite sides are equal. So we're going to know that the side opposing 5a is equal to 5a, and the side opposite 13 is equal to 13. So to find our perimeter of this shape, it would be 5a plus 13 plus 5a plus 13. Now, we're not going to leave it like that, though, because we can simplify this. We can combine like terms. So a like term is numbers by itself without any variables, or numbers that have the same variable. As long as they have the same variable, we can combine them. And then numbers, of course, can be combined as always. So we're going to combine our 13 and our 13 to have 26. And then we're going to combine our 5a and our 5a to have 10a. Now, similar to having proper ways to write language, there are proper ways to write math, and typically, not that I would count this wrong if you didn't do it in this order, but typically we put the numbers without any variables in the last place of an addition problem. So we would want to write 10a plus 26 would be an algebraic expression to figure out the perimeter of this shape. And we could label that units. Okay, now to find the area, then we know that we are going to do base times height, or length times width. So that's going to be 5a times, we can write a parentheses here to show times 13. So this means 5a times 13. It would be fine if you wrote 5a times 13. and then we want that in units squared. Now remember to put this little 2 on the unit, not on the math problem. If you put that 2, remember that's where we would raise something to the second power. That's a math problem, not a label. It's got to be on the unit to be a label. If we put it over here, it would be a math problem. All right, I do want to point out one little thing here. You can absolutely leave your answer like this, 5a times 13 units squared, not a problem at all. But unlike addition, we can combine unlike terms. In other words, I could multiply 5 times 13 to get 65a. So another way to write this answer would be 65a units, and actually I should probably have an s there, units squared. All right, again, optional here, but now we're going to go on to a SWIC and see how well you've retained all of this information. Good job, guys.